Hey, Lee Robinson here from American Sentinel K9. We want to do a short video on breeding dogs, and we're going to talk a little bit about outcrossing, line breeding, and inbreeding, and the differences between the two. I saw some people that were discussing it today, and they really just kind of had it all messed up. They really don't understand the basics of genetics, so we're going to discuss some very basic ideas. All right, and one of the first things that we should know is every dog has two parents because a sperm and an egg is required. All right, so this dog that we just drew here, it's about like some of your pups probably. You have a 2N dog. What does the 2N stand for? Well, the N stands for the genetics. That's the set of DNA. And the 2 because they have two sets. They have one set coming from their father. Half of their DNA comes from their father, that's 1N, and half of their DNA comes from their mother, which is also 1N. So we have a haploid cell, 1N, and another haploid cell, 1N, to create a diploid cell called a zygote, or that's going to end up growing and producing your offspring. So all of us know this. I wanted to start off with some basics that everybody knows, and we're going to build up from that. Okay, and people were discussing what is the difference between outcrossing, line breeding, and inbreeding. All right, well, here's the difference. We're going to draw a square to represent a male, and I'm going to draw a pink circle to represent a female. Okay, now let's say that we started off with two individuals that are not related at all. They share no common ancestors within several generations. So that means the sperm that produced the offspring, these offspring that are produced are going to be 1/2 him and 1/2 her. But let's say we have multiple offspring. So I don't want to write the word offspring because that's one spot. We're going to actually have multiple spots. All right, so let's put multiple spots. When we do that, each one of these has to get their own sperm and their own egg unless they're identical twins. If they're identical twins, then they share 100% of the same DNA unless a mutation occurs after they separate. But we're assuming that we don't have any identical twins. So that means this one has to get an egg also. And that means this one has to get a sperm also. So we have brothers here, okay? And these brothers, there was some debate. This person was saying, well, they have the same parents, so they have the same genetics. No, that's not true. Not at all. What we're going to do to calculate their genetics is we have to look at the connections between the two. We're going to add up the black connections, 1/2 of a half. That means 1/4. All right, so we're going to take 1/2 and we're going to put to a factorial of the times that we see it. So if we connect this individual to this individual, we have to go through the ancestor. They share the same father. So we're going to go 1/2 and 1/2. That's 2 steps through the father. So we're going to write the number 2 here because there's 2 steps. That's our factorial. 1/2 times 1/2. You have a pizza, you cut it in half. After you do that, you cut it in half again a second time. 1/2 of a half, or 1/2 times 1/2 equals 1/4. Okay? Now we have to also go through the mother. So we're going to add to that the factorials through the mother, 1/2 twice to the 2nd power. So we're going to add to that 1/4 again. So what this means is a total of a coefficient of relationship equals 1/2. 1/4 plus 1/4 is 1/2, or 50% COR, coefficient of relationship. So even though they have the same parents, their genetic relationship is only 50%. That's because this male has a father. We're not breeding humans. I'm just drawing a stick figure because it's easier to draw than a dog. And this male has a mother. So even though this male gave a sperm to this son and gave a sperm to this son, that sperm is a combination this sperm is produced 100% by him, but it's produced 50% by him and 50% by her. She made an egg that made up half of the DNA, 50% of that 100. 50% of that sperm comes from her. 50% of that sperm comes from him. So, on some genes, he gets his father, and on some genes, he gets his mother. But there's many genes in here, many parts, many alleles. You got height, hair color, body weight, eye color, metabolism, all kinds of genes going in here. And this one could have got the same gene that one got, but it could have got a different gene that one got, because his may have came from him, or his may have came from her. So about half the time they have the same gene. Imagine that you take a pizza, and you're going to cut this pizza into half, but you don't cut it like this. You cut it into 22,000 spots, and you get half of those spots. Okay, 21 to 23,000, something like that. Those are called loci. The whole pizza represents the genome. The genome is the entire genetic code. It's the genes that make all of me. Okay, so the whole me, the genes that make the whole me, genes that make the whole me, genes, whole me. It's all of my genes. Well, half of my genes come from my father, half of my genes come from my mother. My brother may have the same half, or he may have a different half, because we didn't cut it one time. We cut it into thousands and thousands and thousands of times, and then we get half of those. So overall, they say about 1/4 of those will be the same from him, because it's a half squared. And then 1/4 again through the mother will be the same. So it's a coefficient of relationship of 50%. Okay, even though they're full siblings, they have different genes. The other half was not shared. So, since their parents were not related, let's say that she has brown eyes and he has blue eyes. This one could get a brown-eyed gene, this one could get a blue-eyed gene. If that's, and let's say for some other gene, let's say height, let's say they're tall and short, okay? This one could have got tall, and that one could have got tall. And about half the time, they'll get the same gene, and about half the time they won't, okay? Now, that should explain how siblings are related. But I explained it excessively because there was some people that were saying full siblings are 100% the same. And I was kind of dumbfounded on that because I thought everybody understood this. But so I, told them I'd go ahead and explain it to them. Now, they wanted to know, what is the difference between a father-daughter breeding and a niece and nephew breeding. So let's discuss that. Well, to do that, excuse me, not a niece nephew, I messed up. A father-daughter breeding versus a niece and uncle breeding. So to have an uncle, we have to have either, let me explain what they were asking. All right, that'll be better. So we breed him with a female. All right, so here's our female that comes in. We get a daughter out of that. Okay? They wanted to know, what if we breed this daughter back to this male? Let's call that sire 1. How is that different from breeding this female to her uncle? So he's the sire of her. So it's a father-daughter breeding, or it's a niece-uncle breeding. So how's that different? So we're going to call this one option 1. And we're going to call this one option 2. Okay? Well, when you do a father-daughter breeding, or a uncle-niece breeding, we're going to now change who we're focusing on in the pedigree. So with a father-daughter breeding, you're doubling up on the father because he gives a 50% contribution direct. So when we're ever looking at what's called the COR, we're going to look at the coefficient of relationship from the father and the coefficient of relationship, if there is one, from the mother, assuming that, in this case, mother and fathers are related. So actually, we'll come back to that in just a bit. So in here we have a 50% direct, father 1/2 to the first power because we're looking at the connections from him and the offspring. Him and the offspring. Well, there's one connection, the sperm, direct. Okay? We also have a connection, though, through Delilah. Let's call her daughter Delilah. So the connection through the daughter is the egg that was fertilized by that sperm. That egg, some of that egg comes from him. How much of it? Half of it. Half of the egg. But remember, the egg is only half of the baby's. So now we have to go through 2 arrows again. So we're going to have 1/2 squared. That's going to be our coefficient of relationship, our relationship to a father-daughter breeding. Well, that is 1/2 plus 1/4, or 3/4, which equals 75%. So we are double bred, so to speak, on S1. The reason we call that double bred, come over here, Connor, is if we look at this pedigree, option 1, the sire is the sire of the mother. Okay, let's call this parent 1 and parent 2. Okay, so Delilah was out of the female, and she's not related, so we don't need to worry about her. So Delilah's mother, unrelated. But the sire goes back to parent 1 and parent 2. And here, parent 1, parent 2. But those genes are all coming through him. So we're focusing on him. 50% direct, 50-50. Half of half is 25. So we have a total of 75% relationship of sire 1. Okay? Now let's move on and let's erase option 1 so we can get rid of some confusion. Now we're going to look at option 2. Option 2 is not going to have this 75% COR. It's going to be much lower. In fact, the relationship is now not on these individuals, but is on the parent 1 and parent 2, which is now the great-grandparent this way, and the great-great-grandparent this way. So if we go through the mother, it's parent, grandparent, great-grandparent. Go through the father, it's parent, grandparent. Okay? So we're going to focus now on the parent 1, parent 2. We're going to call them that. So let's call this S2, stud 2. Well, we have a 50% relationship direct through stud 2. But remember that stud 2, half of his DNA comes from his father and half of his DNA comes from his mother. So there's 2 routes. So we have to look at the relationship of parent 1. That's going to be the route through the stud and the route through the mother. Okay, the father and the mother. I did an F before. So if we do that, we can add them together. Well, here we have a half and a half. So 1/2 squared. Here, through the mother, we have half, half, half. All right? Okay? Well, half of that is 1/4. That over there is 1/8. We add that together. We have 2/8 plus 1/8, which 2/8 is, we're going to have 50%, 25%, 12.5. Okay, and then, wait, 50%. Oh, whoops, that says 2/8. So we got 25% plus 12.5%. If we add that together, the coefficient of relationship of this father, of parent 1, is 37.5%. Much, much, much lower. Before, we had a 75% coefficient of relationship. Now we're at half of that on parent 1. But we also have another 75% coefficient of relationship for parent 2. But what about each other? Okay, so the coefficient of relationship, let me make sure I did this right, because I'm kind of jumping fast because of the video. So from parent 1, we've got this route plus this route. So we've got half of half, that's 25%. And that's correct. Okay, so now for parent 2, Since it's the same step, it's going to be the same process, another 37.5%. So we've really reduced the coefficient of relationship by doing an uncle breeding. Okay? Any questions? I hope not, but if so, hit me up. You can stop it.